Good morning, everyone. So, today I will be taking a lecture on the topic classical integrants. Okay, so let's start. So, the prerequisite to learn the classical integrands will be integration by parts. So, you must be very well aware with the formulae of integration by parts and also its applications. So, I have written down the formula as well as an illustration for integration by parts. We know when we apply integration by parts when there is a multiplication of two functions. Suppose one function is x, other is ln x. We know the integration of ln x. In fact, ln x integration also we do it by integration by parts only, and that is illustrated itself. And we know the integration of x. So this way, what we do, but we have when we have to find the integration of x into ln x, we apply integration by parts. And one critical steps in integration by parts is that we have to identify out of the two function which is easily integrable and which is easily differentiable. Because you see, one function is v in both the terms v has been integrated, and u, one place u has remained constant. So the function u has remained constant at one place, and we have taken its derivative at the other place. Okay, so like u function we have to identify in such a way that it is derivable easily, and v function we have to identify in such a way that it is integrated easily. So suppose now we know that we do not know the integration of ln x. Like normal methods, normal chart we study, like integration of sin x, cos x, x to the power n, and everything. There a formula of integration of ln x? No, because we have to do the integration of ln x by integration by parts only. I know you will have one doubt that, sir, you told that it will be a product of two functions, but here it is a single function. Don't worry, like take it as a product of take ln x is equal to 1 into ln x. Now what you have to do, you have to identify the function out of u and v which is easily integrable and which is easily differentiable. You know, you must be aware with a formula of Eilert, okay, that exponential function is like easily integrable out of all functions. Then trigonometry is second, algebraic comes third, logarithmic comes fourth, and inverse comes fifth. Okay, so this Eilert rule you must be aware. So here if you identify ln x is easily differentiable, so we will take it as u, and we will take 1 as v. Now apply the formula. So u is ln x, v is equal to 1. So u as it is, ln x, u is ln x as it is. Now integration of v. So integration of 1 is x. So here that x has remained. It will be ln x into x. Okay. Minus integration of ln x, its differentiation 1 by x, and integration of 1, that is x. That means integration of 1. Resultant will be integration of 1. And integration of 1 is what? X. So it is ln x into x minus x plus c, or we can say x. We can take out x common. It is x into ln x minus 1 plus constant of integration. Never forget about constant of integration in indefinite integration. Okay. So now, if you have not read integration by parts earlier also, so I have given you a brief idea about integration by parts. Now comes classical integrants. So two special formulae of classical integrants. So whenever after I will teach you classical integrants, what do you do? Like be aware whenever you get this pattern, whenever you have observed this pattern, always think of classical integrants using the formula of classical integrants and solving the problem. So what are those patterns? So first is, if you have to find out integration of e to the power x into, there is a function fx and we have added it the function of f dash x, same function's derivative. Then its integration will be e to the power x into f of x plus c. Got my point? Okay. Second pattern will be integration of, suppose there is a function of x and we have added to it x into its same function's derivative. Then its integration will be x into f of x plus c. Okay, I am taking two basic illustration. You will get a hang of this formula easily. So first will be if I have given you this formula, okay, sorry, I have given you this question, how to solve it? So what we will do, we have identified this as f of x and this as f dash x. So we have told you the formula that e to the power x into f of x plus f dash x. What will be its integration? E to the power x into f of x plus c. F of x is sin x plus constant of integration. Let's take another illustration. E to the power x into 1 upon x minus 1 upon x square. We know this is f of x and this is its derivative. 1 by x, derivative of 1 by x is minus 1 by x square. So again, e to the power x into f of x plus c. F of x is 1 upon x plus constant of integration. Okay. Now take another illustration. Log x plus 1. Okay. We have to integrate it. How we can go? We can think of it as log x plus x into 1 by x. We can write 1 in this way. So now it is f of x plus x into f dash x. So what will be its integration? X into f of x. So x into f of x plus c. Take another illustration. Suppose we take sin x plus x cos x. What will be its integration? F of x plus x f dash x. So answer will be x into f of x. Okay. So like now you have got a hang of the formulas of classical integrands. But you'll ask me, sir, that only you have made us cram the formulas. Where is the proof? So the proof of classical integrands comes with the integration by parts itself. Okay, I am showing you. So suppose you have asked me to prove that e to the power x into f of x plus f dash x comes this. So you'll ask me, does it come also? Please show us. Okay. So I have to integrate this. What I will do, can we write it as e to the power x f of x dx plus integration e to the power x f dash x dx. Left hand side, we are operating left hand side. Can we operate it like this? Yes. Addition, we know it, we can do it. Okay, now leave it as it is. Leave it as it is. Now integrate this. We can identify this function as easily integrable. So this is v. This function is easily differentiable. We will take it as u. So u remains as it is. Integration of v, f of x, minus integration of differentiation of this, differentiation of u into integration of this. Plus you can put a constant of integration. And this will remain as it is. Magic. This and this are identical, so they will cut themselves. Final answer, e to the power x into f of x plus c. So I think proof was very, very simple. Okay, so let's get on to the next proof and please note it down. F of x plus x f dash x. We have to integrate it. Again, same way. F of x, keep it as it is. Plus x f dash x dx. Right, dx. Again, this is v, this is u. U as it is, integration of this minus integration of differentiation of this 1 integration of this f of x dx. This was as it is. Again they will cut themselves, so x f of x and a constant of integration put it. Okay, so hence proved Note it down, note down the proof. And you can do the proof by yourself also if you are very well aware from integration by parts. You can do it yourself also. Now comes some problems for practice. So I would like you to try first. Take 4 to 5 minutes and solve all the three questions. Then I will go on solving all of them. Okay. So let's start. First problem. Only you have to rearrange. Once you rearrange the function, it will be very easy. Like pattern you have observed, e to the power x. So we'll look for f of x plus f dash x. See, e to the power x, 1 upon x plus ln x. Okay, this is f of x and this is its derivative. Pattern has been observed. Now just write down the answer, e to the power x f of x. So answer will be e to the power x f of x is ln x plus constant of integration. Okay. Now second one, e to the power x tan x minus ln cos x. Okay, I want you to know one formula of logarithm. Can we write it e to the power x tan x plus ln sec x? Can we write it in this way? See, if there is log and some function is suppose a and there is minus, what happens? This go on ln a to the power minus. Suppose it is 4 ln a, it is equal to ln a to the power 4. So I am applying this. Clear? So now we have to identify. We have clearly know that differentiation of tan x is sec square x. So definitely this is not f of x. Can this be f of x? Differentiate. What is dy dx of ln sec x? Apply chain rule here. Ln of something, so 1 upon sec x. Now differentiation of sec x into tan x. Yes, so this is f of x and this is f dash x. Now just write down the answer. E to the power x f of x. F of x is ln sec x plus c. So we have solved the two problems. Now the third problem. For that I will be needing some space, so I will erase 1 and 2. So please note it down as soon as possible. As soon as you can, please note it down. Note it down. Note this down the solution. Okay, third. X plus sin x upon 1 plus cos x. So what to do? See here, the applicable formula will be of trigonometry, that is half angle formula. So we know 1 plus cos x is equal to 2 cos square x by 2. This formula will be applicable here. So we have to write it down, x plus sin x upon 2 cos square x by 2. Okay. Now break it down. X upon 2 cos square x by 2 plus sin x upon 2 cos square x by 2. Now sin x can be written as 2 sin x by 2 cos x by 2. Write it down. So firstly what we have to do? Half x into sec square x by 2 plus sin x, 2 sin x by 2 cos x by 2, or upon 2 cos square by 2. So 2 cos x by 2 will cut it down. So it will be tan x by 2. Okay. Now differentiation of tan x by 2. What is the differentiation of tan x by 2? If I told you d by dx of tan x by 2 is sec square x by 2 and into half. See, this is f dash x. So this is actually integration of f of x plus x f dash x, and its integration is x f of x plus c. So its integration will be x f of x. F of x is tan x by 2. So it will be x into f of x plus constant of integration. Got it? Okay, please note it down. So we'll move on to one very good problem now. Okay. So this is a JEE advanced standard problem. Like these all were just basics. So this is a problem that can come like of this variety, can come in JEE advanced. So the question is, if integration of e to the power x 2 tan x upon 1 plus tan x plus cos x square x plus pi by 4 dx is equal to e to the power x into g of x plus k, then g of 5 pi by 4. So till now, I think you would have guessed that it is from the pattern 1 of classical integrals, right? Okay. So I will note down this in the next slide. Okay. Now we have to integrate it. Clear? Okay. So we know sine square theta. See, there is x plus pi by 4. So we have some idea that if we make it pi by 2, so pi by 2, how can it be made? If we write it as cosec square half of 2x plus pi by 2. So now cosec square theta by 2. So how it can come? So that we know the formula of cos 2 theta. So we know that sine square theta is equal to 1 minus cos 2 theta by 2. So cosec square theta will be what? Just its reciprocal, that is 2 upon 1 minus cos 2 theta. So cosec square x plus pi by 4 will be what? 2 upon 1 minus cos of 2 theta. Cos of 2x plus pi by 4. 2 into pi by 4. That means cos of pi by 2 plus 2x. Now allied angle formula, cos of pi by 2 plus something, it is minus sine. That means 2 upon 1 plus sine 2x. Okay. So it is integration of e to the power x 2 tan x upon 1 plus tan x plus 2 upon 1 plus sine 2x. Now we have to show some intelligence. Like this is a function in tan x and this is in sine. So convert it in sine. So take 2 outside e to the power x tan x. It will be this. Do you all agree with this step? Now 1 plus sine 2x can be written as 1 plus sine 2x cos square x plus sine square x plus 2 sin x cos x. This will be cos x plus sin x whole square. So this is 2. So 2 we have taken out. So it will be 1. It will remain just 1. Okay. 1 upon cos x plus sin x whole square dx. Now identify this as f of x and find out its derivative. It will come as f dash x. You all do not agree? D by dx of sin x upon, we have to differentiate this function. Okay. So it will be cos x plus sin x whole square. Now cos x plus sin x as it is. Differentiation of sin x, that is cos x, minus sin x as it is. Differentiation of cos x plus sin x. See what it has come. Cos square x plus sin x cos x plus sin square x minus sin x cos x. And we very well know that cos square x plus sin square x is equal to 1. So this is f dash x. So it has been set in our agenda, that is e to the power x f of x plus f dash x. Its integration will be e to the power x into f of x. So f of x is what? This. So 2 into e to the power x okay. Now it is g of x plus k. So e to the power x into g of x. So g of x, if we compare it, g of x will be sin x upon cos x plus sin x. Okay. So g of 5 pi by 4. It will be equal to sin pi 5 pi by 4 upon cos 5 pi by 4 plus sin 5 pi by 4. 5 pi by 4 is an angle in third quadrant. Both will be negative. So it is minus 1 upon root 2. Okay. And g of x is equal to 2 sin x actually. Into 2. We have forgotten that. Into 2 actually. Yes, 2. Okay. So it is actually 1. Option number B will be correct. Okay. So thank you everyone. The lecture ends here. Thank you.